Section 5.1, we get into simulations. So chapter 5, we kind of switch gears a little bit. We're not so much with a normal curve anymore. We start working with probability and simulation. So the first essential question is, how do I perform a probability simulation? What is the probability of flipping a coin and getting tails? Is it 50%? Let's find out. Everyone flip their coin 10 times and record the results. So if we were in class right now, we'd all have a coin and we'd flip it 10 times and we'd see what we get. It should be about 50%, but I bet that most of us do not get 5 heads and 5 tails. So it says, now let's combine the data to see if 50% is correct or not. So if we were in class, we'd kind of total all of this up and see how close we were to 50-50. We would see that the more trials, the more accurate our estimate might be. This is an example of probability simulation. So for example, if I flip a coin 5 times, I could get 5 heads. That doesn't mean that heads is 1,000% or 100%. What that does mean is that the more times you do it, okay, so if I would do it 100 times, odds are I'd be pretty close to 50 times tails, 50 times heads. It might be like 40, 60, but if you did it 1,000,000 times, it's much more likely to be closer to 50-50. So probability simulations simulate the chances of something happening, such as flipping a coin. So probability simulation is the process of carrying out an experiment many times to record and calculate the relative frequency results in order to determine the likelihood of a result. Make sure I spell this right. So you're going to find out the likelihood of something happening. So it is the imitation of chance. Imitation of chance behavior using a trustworthy model that accurately reflects the problem. You can use random integer table. So we actually are going to use the random integer table. If you have it, you can take it out. The random integer table looks like this. So if you have this, take it out. If not, it is on Canvas. You can find it. Click on it, download it, print it if you can. You will use this a little bit this chapter. All right, and it is a method used to find good estimates for probabilities. And that's what they are, is estimates. Like if I said flip a coin 10 times, you would estimate you'd get about 5 tails and 5 heads. It doesn't mean that's what you're going to get. Okay. So the 5-step simulation plan. State the problem, or describe the experiment. Step 2 is state the assumptions. Step 3 is assign digits to represent outcomes. Step 4 is simulate many repetitions. And step 5 is state your conclusions. So we'll follow those 5 steps. Independent trials are trials in the same simulation that stand separate from each other. One trial has no effect on the outcome of another trial. Okay, so for example, if I flip a coin and roll a dice, me flipping the coin is not going to affect what number I roll on the dice. All right, so example 1. Assume the likelihood of a person having green eyes is 20%. If I randomly select 40 individuals, use a simulation to find the percent that would have green eyes. Okay, so 20%, if we simulate 20%, it would be 2 out of 10. So we have 10 single-digit numbers. The 10 single-digit numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you want to do a simulation, 20% would be 2 out of 10. Okay, so that means that the numbers 0 to 1 would be green. And the numbers 2 through 9 will be not green. Okay, so 2 out of 10 would be green, 8 out of 10 would be not green. And we're going to try to simulate to see what we would get. So we're going to pick line 101. It doesn't say which line to pick. We're just going to pick line 101. Okay, and we're going to tally how many greens and how many not greens for the first 40. So we need to select 40 individuals. That means we pick the first 40 numbers on line 101. So I'm going to scroll down to line 101. Let's do the first 5. We'll do 5 at a time. Okay, so line 101. Remember, 0s and 1s are green. 2 through 9 is not green. So in the first 5, right here is the first 5. How many are 0s or 1s? There's 1. How many are not? So we have 4 nots and 1 yes. Let's try the next 5. How many are 0 or 1? There's 1 0, and then the 9, the 5, the 3, and the 4 are not 0. Okay, so let's go back up. We got 2 check marks, 8 X's. So 2 greens and 8 not greens. So you go back up and you tally 1, 2, and not green would be 1, 2, 3, 4, 5, 6, 7, 8. Can you keep going? So 2 of the numbers were 0 or 1. 8 of the numbers were 2 through 9. So I'm going to scroll down to the chart again. You can just have your chart right next to you and keep going. So the next number is 0. That would be a yes, green. 5 is not green. 7 is not green. 5 is not green. 6 is not green. So we have 1 more green, 4 more not. 2 is not green. 8 is not green. 7 is not green. 1 is green. And 3 is not green. Okay, for the next 10, we got 2 green and 8 not green. Actually, I can do this. Green, green. 2 green and 8 not green. So I'm going to scroll back up. One, 2 more green. 1, 2, 3, 4, 5, 6, 7, 8 not green. So that's 20. We did 10 and 10. So we got to do 20 more. So we're going to do 5, 10, 15, 20 more. Let's do all 20 together. Let's count how many are going to be green. How many 0s or 1s? So we have 9, 6, 4, 0, 9, 1, 2, 5, 3, 1, 4, 2, 5, 4, 4, 8, 2, 8, 5, 3. So we got 3 greens, and we have, remember, 9 is not green. 6 is not green. 4 is not green. 9 is not green. 2 is not. 5 is not. 3 is not. 4 is not. 2 is not. 5 is not. 4 is not. 4 is not. 8 is not. 2 is not. 8 is not. 5 is not. 3 is not. So we have 3 greens, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 not. So 3 greens, 17 not greens from that line. So that's 1, 2, 3 greens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so if we look, in this simulation we had 7 green and we had 5, 10, 15, 20, 30, 33 not. So 7 and 33. So if it was perfect, like what we would predict, there would have been actually 8 of them green and 32 not green. But in this simulation, we got 7 and 33. So we used our number line to simulate that. What we did is we assigned 2 numbers to be the green, and we assigned the rest of the numbers as not green. And then we just use those numbers to tally up what we got for our simulation. Okay, so that is how we perform a simulation with the number chart. Okay, example 2 says, the problem is, what is the probability of a couple having a girl among the first 4 of their children? So if husband and wife have 4 children, what is the probability of them having a girl among those 4? Okay, and what this means, if they have a girl, all that means is you have at least one girl. It doesn't mean just one girl. It means you have at least one. So you could have 1 girl and 3 boys, 2 girls and 2 boys, 3 girls and 1 boy, or all girls. This means you have at least one girl. So the assumption is we will assume that having a boy or a girl is equally likely, which as far as I know that is true. It's equally likely to have a boy or girl. The gender of each child is independent of another. So all that means as independent is if the first child's a boy, it's not going to have any effect on the second child. All right, the second child that you have has 0 effect on the first child. You could have a boy and then a girl, or a boy and then a boy. It really has no effect on it. The assignment is we want to assign a single number digits to represent a boy and a girl. Okay. And for this one, let's do the boy is even and the girl will be odds. Okay, because the evens and odds are equally likely to come up. And I just want to point out that there are other options. Right? You could pick 0 through 4 are boys, 5 through 9 are girls. You just have to have 5 of each. 5 would be for boys, 5 would be for girls. All right, and it says we want to look up random numbers from the chart in groups of 4. Okay, so what this means is since there's 4 kids, we pick groups of 4 numbers. Not just one at a time, it's groups of 4. So like here's 4 kids, then the next 4 kids, and the next 4 kids. And it says, let's do this 10 times. Okay, so in the first 4, okay, this is from line 120, by the way. It's right here in your notes. So the first 4 are 3, 5, 4, 7. Okay, so we just want to find out, is there going to be at least one girl? So girls are odds, boys are even. So in this one, the 4 would represent a boy, and the 3 is girl, 5 is girl, 7 is girl. So in this one, how many, or is there a girl? Is there at least one girl? The answer is yes. Okay. In the second group of 4, we would have girl, 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 and the first one, 6 is even, so that would be a boy. So this second group is also having a girl. So think of it this way. In this number set, if this was a simulation, it would be like having a girl, then another girl, and then your third child's a boy, and then the 4th child's a girl. That'd be the first 4 children. Okay. The second one would be like having a boy, and then having a girl, girl, girl. Okay, so I'm 3 girls in a row, because odds are girls, evens are boys. The next one would be like girl, boy, girl, girl. So is there at least one girl? Yes. The next one would be boy, boy, girl, boy. So is there at least a girl? Yes. The next one would be girl, boy, boy, girl, boy. Is there at least one girl? Yes. So now I'm just going to look. You get the point now. There's 4 kids. Evens are boys, odds are girls. So I'm just going to look at this and see, are there any odds? So in the next one, this would be boy, 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 boy. This one will be no girl. Okay, so no girls in this one. This would be like somebody having 4 kids, they're all boys. The next one, 3 would be a girl, so that one would work. The next one, 3, 5, and 3 are girls, so that would work. And then we have girl, so that last one works. Actually, it's not our last one. We have one more. 1937 will be like all 4 girls. So of that, the only one that did not work was this one here. The 0426 was all boys. The rest of them, there was at least one girl. Some had more than one, but there was at least one. So out of the 10 repetitions, so it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 repetitions. Of these 10 repetitions, we found that one time, which would have been the 6th rep, the 0426, is where you would not have a girl. That's the one time we got where there's not going to be a girl. So it looks like it's very, very likely if you have 4 kids that one of the 4 kids would be a girl. So our conclusion is there seems to be a 9 out of 10 chance of having at least one girl of the first 4 children. So it looks like there's about a 90% chance. Okay, based on our simulation. There actually is a way to try to calculate this mathematically. We're going to learn that throughout the chapter. All right, example 3. In tossing a coin 10 times, what is the likelihood of getting a run of 3 consecutive heads or 3 consecutive tails? Okay, so this means 3 in a row. And by the way, it means at least once. So a run of 3 at least once of the 10 times. So it could be heads, 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 tails, heads, tails, head, tails, heads, because there's 10 flips of the coin. So the assumption is a head or tail is equally likely. Each of the tosses is independent of the other. Okay, so our assignments, let's do, this time we'll do 0 through 4 is heads. We'll do 5 through 9 is tails. And again, this could be different. We just got to pick 2 sets of numbers that have the same amount of numbers in each because heads and tails are equivalent. So our simulation, everyone pick at least 30 numbers and record the results so we can combine them to create a relative frequency for the class. I'm going to use line 101. You can pick any line. So here's line 101. So if we look, 0 through 4 are heads, 5 through 9 are tails. We're looking for a consecutive 3. So if we look in the first one, is there ever 3 in a row? So if you look, we have 2, 2, 3, and 0, 3, 4. Those are both groups of 3 and 3 numbers between 0 and 4. So this one is yes. This happens here. In the second group, 5, 7, 5, 6. So 5, 7, 5, 6, all those numbers are between 5 and 9. So this is also yes. In the last group, 9, 6, 4, 0, 9, 1, 2, 5, 3, 1. There's never a set of 3 that are in those groups. So from my list, I find that 2 out of 3 times where I get a run of 3 heads or 3 tails. So like right here, this would be like heads, heads, heads. And over here in this one, the middle one would be like having tails 4 times in a row. So the number of successful repetitions, the number of total repetitions would be 3 times the number of students in class, because we each would do this 3 times, is going to equal the total trials. So 3 times the number of kids in class would be total trials. And like I said, if we were in school right now, we would each be doing this with our own line on our number chart. So for our conclusion, there seems to be, we would put our number of successes here and our total number of trials here. Okay, and we don't actually have the calculator because we're not actually in school to calculate it. Okay, the last part. Examples of assigning digits to a simulation. Choose a person at random from a group of which 60% have blue eyes. So 60% have blue eyes, that means 6 out of 10. So when you assign the numbers, I'm going to just pick the first 6 numbers. Would be 0 through 5. Would be blue. And everything else, so 6 through 9 would be not blue. Okay. And in number 2, it says, choose a person at random from a group of which 67% have blue eyes. So 67% is 67 out of 100. So your first 67 numbers, which would be 00 through 67, that would be blue. And then 68 through 99 would be not blue. So sometimes when these numbers aren't out of 10, like 60 was out of 10, 67 cannot be out of 10, so you make it out of 100, so it goes from 00 to 99. And that's just trying to choose the numbers that will represent blue and not blue. Right, that's all we got for today.